how was the midterm exam?
Alhamdulillah.
Alhamdulillah. Okay. Yeah, about the midterm exam, it's only about 39 students who submitting the work. So one student is not submitting. Yasir di sini, Yasir? Yasir
Iya
ada?
Bu, saya hadir.
Iya, nggak submit kemarin.
Hadir Bu. Kemarin itu emang sedang nggak bisa buat melaksanakan ujian Bu. Karena kondisi sedang sakit jadi nggak bisa bangun buat ngerjain Bu.
Oh gitu, kok nggak menyampaikan, nggak kontak saya sebelumnya?
Itu juga kayak dadakan Bu. Jadi saya baru ngeh kalau misalnya nggak bisa ngapa-ngapain gitu Bu. Dan ya udah karena saya juga nggak punya nomornya Ibu, nggak punya kontaknya Ibu, jadi belum ngabarin Bu. Saya minta maaf soal itu.
Ya kan bisa, sebetulnya bisa tanya sama teman-teman ya. Sudah tergabung di grup ya?
Kalau grup WhatsApp, kalau grup lainnya sudah Bu sama teman-teman. Tapi kalau untuk misalnya ada grup lain, sepertinya belum Bu.
Halo? Halo? Bisa dengar?
Halo Bu, suara
Ya.
saya terdengar Bu.
Iya, iya, iya. Tadi saya mungkin agak putus-putus ya. Ya.
Siap Bu.
Gimana tadi? Nggak
Eh,
tergabung di grup WhatsApp?
Kalau grup WhatsApp enggak Bu, karena HP saya juga sedang bermasalah Bu, nggak bisa buka WhatsApp. Lagi mau coba di servis hari ini.
Iya, ini seharusnya ada pemberitahuan lebih awal ya kalau memang nggak bisa nggak bisa mengikuti ujian. Oke, nanti tolong kontak saya lagi ya.
Baik,
Nanti kita
siap laksanakan
pikirkan
Bu.
lagi.
Siap.
Okay, so I hope this is not happening again next time. Yeah, this is very important that you give a notice before. Yeah, even though if you are sick, as soon as you feel better, you should contact me. Yeah. So this is not only for this course, but also for the other course. Yeah. So this is very important. Yeah. So you have to do this seriously. Yeah. Okay. Now, I was planning to discuss the midterm exam, but because we have one student who has not performed the midterm exam yet, so we will postpone that. Now we will continue first to the topic. Yeah, so we will discuss about curve fitting this morning. Yeah, and we will discuss about the explanation for the midterm exam next week. Yeah. Okay, so that yeah, we will continue to curve fitting. Yeah. Okay, so this is in part 5, yeah, in which we are going to learn to find an equations which will fit, yeah, a data set. Yeah. So dealing with curve fitting in part 5, we will learn two methods, yeah, two general approach for curve fitting. The first one is to fit a regression, yeah, a regression or a trend line. Yeah, so we will give a trend line to a data set. So that with this square regression, the strategy is to derive a single curve. Yeah, so we will try to find a single curve that represents the general trend of the data. So this will be all of the data. Yeah. Okay, so all of the data will be represented by a single curve. So this is least square regression. And the next one is about interpolation. Yeah. So if we have, for example, several points, yeah, and then we want to find the data in between of those points, yeah, so that we can find the interpolated value, yeah, in which, for example, in say in thermodynamics, we have learned of to the linear interpolation to find the properties, yeah, of a substance, for example, if it's not available in the table, yeah. So that the easiest way to do interpolation is just using the linear interpolation. Yeah, it means that we connect the two data points that we have with a single line, and then we find, we approximate the unknown value. Yeah, so for example, we have two data points, and then we have to find the value here. So this is the one that is asked. What is the value? Yeah. So we, for example, we have a certain x value, and then we have to find the function, yeah, for this x value. So that how to get this value is to by connecting a linear line. So this will be the approximated value. So this is the simplest one, which is the linear interpolation. Now we will learn of about interpolation later, in which we can apply a more accurate scheme in which we can apply higher order equations to get the linear to get the interpolated value. But today we are going to discuss regression first. Yeah, so we will try to find a trend line that will fit the data that we have. Okay. So why this is important? Because there are many applications of the curve fitting. Yeah. So if you do experiment later, say you have you do experiment for the final project, so that you will need to analyze the result. So with trend analysis, it means that we need to find the curve, the trend line, yeah, and also sometimes we need to predict the data beyond, yeah, or extrapolation, or also the data in between the data points that we have. So this will be interpolation. And also sometimes we want to test whether our result is already in line, yeah, in line with the theory. Yeah, for example, in the theory we have a certain equations, and that with the curve fitting, so that we can get the empirical correlation. Yeah, we can get the empirical correlation, and then we test it. We compare that with the theory that we have. Yeah, so this is about hypothesis testing. Okay, so we will see that we can apply first the least square regression. So for example, here we have 5 points of data, 5 points of data. And then here we can represent this data with a single line, in which here we have a linear line. Yeah, and so that we want to find the equation for this line in which the error will be minimum. Yeah, because when we talk about data points, it means that we have many data. And how to calculate the error? So if we want to have the trend line to be as accurate as possible, it means that for all of the data points here, the error will be minimum. Yeah. So actually, if we want to make a linear line, it can be any linear line. It can be like this, yeah, or it can be like that. Yeah. So it can be any line, but the question is how to get the line that will give the minimum error for all of the data there. Yeah. And also sometimes you want to do interpolations. Yeah. So if you see the graph B here, in which about interpolation, the simplest one is what we have talked before. Yeah, is about connecting the data points with a linear line. So this is the simplest one. So for example, you want to find the data here. So this will be the approximated value for the interpolated or the interpolated value. If you want to have a higher degree approach, so that we can use the curvilinear interpolation. Yeah, curvilinear interpolation, in which we connect this data point with a curve. Yeah, and this curve can be, for example, second order, third order, or fourth order, and so on. And if, for example, we want to find the interpolated value here, so this value will be different to what we have here. Yeah, so this will give a more accurate result. Okay, so that before we discuss about the curve fitting, so we will look again on the mathematical background, because we will have lots of data and we will dealing with the error of those data. So it's important that this will relates to a little bit in statistics. Yeah. So when we look at the mathematical background, so when we have several data, for example, yeah, we have many data, for example, from I equals to 1 up to n. So n is the number of data points, so that we can find the average of the data by calculating the y bar, or the average, or this is called the arithmetic mean. Yeah, that will be equals to sigma yi over n. So that we add the value of y1, y2 up to yn and divide it by the number of the data that we have. So this is how to find the mean value or the average value. And when we talk about statistics, so we also have the terms of standard deviation. So what is a standard deviation? So this is actually the measure of the spread. Yeah, so this is the measure of the spread. So for example, here we can calculate, say we have n data points as before. Yeah, so that SY, or the standard deviation, can be calculated by the square root of ST divided by n minus 1, in which ST here is the summation of yi minus y bar. So the difference between the value of the data to the average value, and this is squared. Yeah, so this is ST. So we sum the difference with the average, yeah, and this difference is squared. So this is how to calculate the standard deviation. And also we have the terms of variance. So variance is actually similar to standard deviation, but variance here is the squared value of standard deviation. So almost the same representation. So this is the spread of the data, and this is shown by the square of the standard deviation. So the calculation will be similar. Or further, if we want to calculate this one, so that will be sigma yi, so this yi squared, minus sigma yi squared over n. Yeah, so this is the y bar value is sigma yi squared over n. Yeah, so this is similar, over n minus 1. And we also have the terms of coefficient of variation. So this is the utility to quantify the spread of the data. Yeah. So we want to quantify how large is the spread of the data. So this will be normalized. Yeah. So it's coefficient because this is normalized with the value of the average. Okay, so this is a term that we have in statistics. And why we learn this? Because we will use a very analog approach, yeah, to find the curve fitting. And if we learn about the distribution in statistics, so for example, we have the several data points, and then we can draw this value versus the frequency, so that we can see, for example, for the data points, for example, one value of 6.6, we have how many times the value appears. So that will be the frequency. So this, in general, we will have the standard distribution like this one, yeah, or we can say that as a normal distribution. Yeah, a normal distribution means that the most frequent will appear close to the mean value. Yeah, and this how wide the normal distribution Yeah, so the width of the normal distribution that's represent the spread. If if it's have a wider dome, yeah, a wider dome, it means that the spread is greater. Yeah, so the data has a greater spread. But if we have a, um, a smaller width, yeah, so it means that the spread is also smaller. Yeah, so this is dealing with normal distribution. Okay, so that now we will see how we can apply similarly to get the regression, yeah, which is called the least squares regression. Okay, so we will try to analyze a data set. Yeah, so for example, we have 1, 2, 3, 4, 5, 6, and 7. We have 6 points, and here we can try to find the fitting, yeah, for this data. So for example, B, if we want to apply polynomial fitting, yeah, polynomial, so we will have a polynomial oscillating curve, yeah, for the data. Or we can also approximate that, yeah, approximate that with a value here, with a curve fitting in which this is only a linear line, for example, like this one. Yeah. So here, in this case, we don't have the oscillation, yeah, but we have an error value here. Yeah. So because when we make a curve fitting, it means that when we want to find a value of x, so the value of the function for a certain x will be here. Yeah. So based on the calculation, based on the trend line that we have, on the curve fitting that we have. So this will be the approximated value, yeah, using the curve fitting. While this one is the actual data. So we see here that there will be an error. And when we want to analyze the error for this, so that means we have many data, and that means we have to find a single curve, yeah, or a single line in which that will minimize the error for all of the data. Yeah, so this is the big question. Okay, so say we have n data points in which for each of the data we have the value of xi and yi, so that if we want to fit a straight line, so that the straight line will have a general equation of y, which is equals to a0 plus a1 times x plus the error, yeah, or the residual between the model and the observation. So this means the difference between our calculated value using the fitting with the actual data. Yeah, so that this is also similar. Yeah, usually we write down the linear line as y is equals to mx plus c. So here m is the slope. So here a1 is the slope or the gradient of the line, and c is the intercept. So this is the point in which it will cross the y-axis. Yeah. So if we look at here, say we have the measured data here. So this is the actual data points. And then because of we want to fit a regression line with the other data, so that here is the regression line that we have. So that if we want to find the value of xi based on the data, the trend line or the curve fitting or the regression line that we have, so that the value here will be y, which is equals to a0 plus a1 xi. Yeah, so based on this one. Yeah, so y is equal to a0 plus a1 times x. So this will be the value from the regression line. While the actual data is here, so this will be the error. So that if we want to calculate the error of the data of one data point, so that will be equals to yi, yeah, the actual value, minus y. So that will be yi minus a0 minus, yeah, so we have minus sign in front, so that will be minus a1 xi. So this will be the error. Okay. So the next question is how to get the data that will minimize the error for all of the data points. Yeah. Okay. So how to find the value of A0 and A1 so that the error will be minimum. Okay. So now when we talk about how to find the criteria for the minimum, yeah, the minimum criteria, so that now we can see, we can try the first approach in which we want to minimize the error so that the error here is only calculated by doing the summation of the error. Yeah. So for example, here we try to find sigma yi minus y0, which is y0 is the approximated value, yeah, from the trend line, for example. So that here, if we want to minimize this one, the summation, so that this will have a result in which this can produce an accurate result. Yeah. So for example, like this one, say we have a data, yeah, and then we have the approximated value here. Yeah, we have the trend line like this one, for example. So this is the actual data that we have. And then we have the, for example, the trend line that we have like this one. So then when we find the error, so this error will be, for example, negative, and this error will be positive. So then when it will be negative and positive, so that the result is that this looks like 0. Yeah. So then we believe that if we can minimize this one to 0, it means that we have a correct result. But actually, the result is incorrect. So this is the approximation. So it means that we cannot use this criteria to find the best fit. Yeah, so that we cannot minimize the summation of the error. So we think of the other way in which, for example, we want to minimize the absolute sign. Yeah, if we want to minimize the absolute sign. Yeah, so if we want to minimize the absolute sign as well, yeah, so that although it will be always positive for the value, but also this will not be a correct solution as well. Yeah, so this will not be a correct solution as well, because sometimes we have a data, for example, yeah, in which say we have this data, yeah, we have this data, so that we have this data will give the approximate the same level of error to this data. Yeah, and we believe that to be the best to be the best fitting, but actually the best fitting should be lies in the middle. So this will not be the best criteria as well. Yeah, not a good criteria to find the best fitting. So that now we try to, for example, find the maximum and try to minimize the maximum. So this will pose us a problem as well. Yeah. So for example, if we want to find the largest error, yeah, the largest error, and then we want to minimize the largest error. So this can be a problem as well. For example, yeah, if we have several data that gives the same level of error, yeah, gives the same error. So in this case, we cannot minimize that. Okay, so what is used to minimize the error? So here we use the squared value of the error. Yeah. So how to get the best fitting is to minimize the squared value of the error. So that's why it's called least squares. Yeah. So the value is squared. Yeah. So that SR here, yeah, SR is calculated by the summation of the squared error for each of the data points. Yeah. So that the error itself will be yi measured minus yi from the model or from the trend line, which is squared. Yeah. And this error is squared, the residual is squared. So that will give this value. Yeah. So that will be SR will be equals to a sigma yi minus A0 minus A1 xi, and this error is squared. And we do the summation for all of the data that we have. And the goal is to minimize this error, to minimize the SR value. So that when we minimize this one, so this will yield a unique line for a given set of data. It means that we will not have many lines. We have one unique solution, one unique line. And this will minimize the error for the data. Okay, so how can we perform to find the minimum value of this one? So again, if we have a curve, and we want to find the minimum value, so that it means that we can find it by find the value in which the gradient is 0. So that how to find the coefficient of A0 and A1 that minimize this value so that it should satisfy this condition. So that the gradient of SR to A0 should be equal to 0. And the gradient of SR in respect to A1 is also should equal to 0. So that will give a coefficient of A0 and A1 that will ensure that the error will be minimum for the trend line that we have. Okay, so that with finding this gradient, so it means that we have to further find the derivative of these equations in regards to A0 and A1. Okay, so this is the calculation. So then when we find the regressions, again here, I will write down so that we have sigma yi minus minus A0 minus A1 xi, which is squared. So then this is the function of SR. If we want to find the gradient, so that we have del SR over del A0, so that will be equals to sigma. Here we have yi minus A0, and now we want to find in respect to A0, so that will be 2, so because this one is A squared, so that will be minus 2. So we do substitution so that here we have yi minus A0 squared, so that will be minus 2A0 minus A1 xi. So this will be the derivative. And again, similarly to that one, now we want to find the derivative in respect to A1. Now, because A1 here has the value of xi, and this is squared, so that with this, it will be minus 2 yi A0 minus A1 xi times xi, because we have here squared value, so that will appear xi as well here. Okay, so that now this will be equal to 0 to ensure that we minimize the value. So that means that with this one, we can get that the summation itself, which is minus sigma yi minus A0 minus A1 xi, that should be equal to 0. Or further, we can calculate that with sigma yi here, minus sigma A0 minus sigma A1 xi. And again, the same apply for the second equation, so that now we have sigma xi yi, yi xi, minus sigma sigma A0 xi, and then next we have minus sigma A1 xi squared. So that means we have now 2 equations with 2 unknowns. And further to calculate this one, because A0 is a coefficient, so it doesn't have a value of I here. So the summation itself will be n times A0. So that again, we can insert that, we can substitute it here. So that now we have NA, move that to the left, NA0 plus, move that to the left, plus sigma xi A1, that will be equals to sigma yi. And the second equation here we have sigma yi xi, that will be equals, move that to the left, sigma a0 xi plus sigma a1 xi squared. So that now here we have two equations to be solved to find two unknowns, which is a0 and a1. So this is our goal. So that performing the substitution, when we want to perform the substitution here, so that now we can have the value of a1. So that will be equals to n sigma xi yi minus sigma xi times sigma yi divided by n times sigma xi, which is squared, minus sigma xi, and this summation is squared. So you see the difference between this term and this one. So it's different, yeah? So this one means that we have to find the summation of x first, and then we square the value of the summation, while this one means that we have to square the value first, and then we do the summation of the squared value. So this is to find the slope. Yeah, so how we obtain that? By substituting this value, yeah? So that we can substitute this value of a1 here, yeah, with this equation. Yeah, we insert it here so that we will have this calculation. And what about a0? For a0, so that will be equals to the average value of y minus a1, which is the slope, times the average value of x. So that will be the intercept. Okay, so it means that once we have this formula, it's very easy to find these equations, yeah. So then we can find a0 and a1. So that when we find a0 and a1, so that we have the complete equation for the linear line. Okay. Okay. So remember again that once we have this equation, so that will be this value, yeah. For example, if we want to find it at certain value of xi, so that again the error, that will be the difference. Yeah, so that will be E, the error will be yi minus y from the model or the trend line. Okay, so that now, aside from getting the trend line, aside from getting the linear equations, which will be the trend line, we also need to analyze the error. Yeah, and how to analyze the error? So that now we will use what we have learned in analog in the statistics, so that we have the calculation of SR here, in which this is the one that we want to minimize, which is equals to the summation of EI squared, in which this is the error for all of the data points. So that it means that for each of the data, we have to find the error and then square the value, and then we do the summation for all of the data. So that again, similarly to what we have learned in the standard deviation, so that we can also calculate the standard error of the estimates. Yeah. So that will be equals to the square root of SR now divided by n minus 2. Yeah, n minus 2. Okay, so once we have this value, we can calculate the error, yeah, and then we can calculate SR so that we can calculate the standard error of estimates. So what is actually here when we talk about SR, yeah, or also when we talk about the standard error of estimates? So this is very similar to standard deviation. It means that if we have large value, if we have the large value of SR or the large value of standard error of the estimates here, it means that we have a wide distribution here. So it means that the data that we have, yeah, the data that we have here, for example, we have this set of data, and then we create this trend line here, so the horizontal line as the trend line. So we will see here that we have the error for each of the data there. And this the normal distribution here shows the error, the level of the error for all of the data that we have. So if we have wider here, it means that we have several data which has a very large error. Yeah, if we have a wide normal distribution, or it means that if we have a large value of standard error of estimates, it means that we have some value which is which has a very large error. Yeah. So what we want to have is actually shown in the right side here. Yeah. So for example, we have exactly the same data shown here, but we use different trend line here. Yeah, we use a different trend line here. So we see here that the error will be smaller. Yeah, even the largest error here. Yeah, approximately like this. So then when we draw the normal distribution, so we can see that most of the data, yeah, fall very close to the trend line that we have. So the frequency that close to the trend line will be higher compared to this one. Yeah. So we see here that if the peak value is lower, it means that the frequency of the data which is close to the trend line here will be not too many. Yeah. So if we have this one, it means that the peak, the higher the peak, it means that the frequency of the data which is close to the trend line is higher. Yeah. And also if we look at the width, yeah, the width of the dome here, which for the normal distributions, if the width is smaller, it means that the error, the maximum error for the data there will be smaller compared to this one. Yeah. So we see here that this will be the error maximum. Okay, so our goal is that after we get the trend line is that we want to make sure that the standard error of estimates will be low. Yeah, it means that it will have a small normal distribution. Yeah, yeah. Okay, so we see here that if, for example, we have a smaller standard error of estimates, it means that we have smaller residual error. Well, in this case, we have larger residual error. So we can see that several data here as an error which is quite large. Yeah. Yeah. So this means that it will have more, it will have wider, yeah, wider curve for the normal distribution. Okay. So that again, we can calculate, we can find the comparison between what we have in the statistic, which is the standard deviation, yeah, relates to the standard deviation. We have ST, which is the total sum of the squares around the mean. So if we have a mean value, yeah, so this is based on the statistic, so that we can calculate ST, which is equal to the summation of YI minus Y average, and this value is squared. So the difference, yeah, the difference between the value and the mean value. Well, we also have the calculation of SR as what we seen before, which is SR is the squared value of the residual, yeah, around the regression line. So that here we'll have this calculation. So then if we do the comparison here, we can have the error quantification, in which this is called the coefficient of determination, which is called R squared value. So R squared value here is ST, which is the deviation, yeah, the deviation from the mean value, minus SR, which is the residual to the trend line, over ST. So that we will have the difference between in the statistics and from the trend line itself. So that if, say, we have the R squared value is equals to 1, yeah, or we have SR value which is equals to 0, yeah, if we have R squared value is 1, so that means that is 0. It means that the line explains 100% of the variability of the data. So what does that mean? It means that all of the data will exactly in the trend line. Yeah, because the error is 0. It means that all of the value will be exactly at the trend line. So for example, we have this trend line, so all the data will fall exactly in the trend line. So that means that we have R squared value, or if we want to find R, which is said to be correlation coefficient, so R, that will be the square root of ST minus SR over ST. Yeah, similar. Yeah, so that means if we have this value of 1, so it means that 100% of the variability of the data is represented by the trend line. On the other hand, if we have R squared value close to 0 or even 0, it means that that fit the fit represents no improvement. It means that all of the data is far away from the trend line. So the trend line means that the trend line fails to explain the data. Yeah. So this is not a good trend. So what we want to have is to get the trend line that will be as close as possible to the value of 1 for the R-squared value. Yeah. So the closer it is to 1 to 1, yeah, the value to 1, so it means that it's a better representation for the data. Yeah. Okay, so we will look at the example here. Okay, so this is the example. Say we have 1, 2, 3, up to 7. We have 7 data points. We have the X value and also the Y value here. And here we want to fit a straight line to the X and Y values in the following table. Yeah, so that if we have X and Y, yeah, X and Y, it means that, again, we will look at the equations here. What we need to calculate A1 and E0 is that we need to find the summation of Xi times Yi, and also we need the summation of sigma Xi, we need the summation of Yi, we need the summation of Xi and also Xi squared. Yeah. And also we need to calculate the average value of Y and X, the mean value. Yeah. So this is what we need to find, so that now it's easier to put it in the table. Yeah. So that now we find the value of Xi times Yi, so that we calculate Xi times Yi. So 1 times 0.5, that will be 0.5. And also we have 2 times 2.5, that will be 5, and so on. And then we need also the information of sigma Xi. Yeah, so that we need the information of Xi squared, so that we insert the column here, which is Xi squared. So this will be the squared value of Xi. So we just insert that. 2 squared is 4, 3 squared is 9, and so on. And then we need to find the summation, because we need sigma Xi. So that now we find the summation here for sigma Xi is here. And this will be sigma Yi. And this will be sigma Xi Yi, and so on. Yeah, so this will be sigma Xi squared. So once we have this value, then we can write down the summation. So these are the summation. And also we can find the average or the mean value. So that X bar will be sigma X divided by the number of data. So that sigma Xi will be 28 divided by, we have 7 points, so that divided by 7. So the result is 4. And also we need to find Y bar, the mean value of Y. So that will be sigma Yi, which is 24, divided by the number of points, which is 7. So the result will be 3.4. So once we have this data, and then we can use that in the formula that we have. So A1 is equals to N times sigma Xi. So we have the value of sigma Xi, Yi already. N is 7. Minus sigma Xi, we have the value as well here, sigma Xi and sigma Yi. So we just insert it there. Now this is divided by N. N is number of points, 7, times Xi squared, the summation of Xi squared. So we find here the summation of Xi squared, that will be 140. Yeah, so we insert it here, 140 minus sigma Xi value. So sigma Xi value is 28, and this is squared. So that we get the value of the slope here is 0.839. And now how to calculate for A0? So that will be equals to the average or the mean value of Y minus A1 times X bar, yeah, mean X. So that we insert the value of the average value here for Y and X here. And this A1 value is known already, so we can insert it here. So that we have A0. So that Y, equation of Y will be A0 plus A1X. So that we have Y will be equals to A0, this one, plus A1 times X. So then if we want to find, for example, the value of X at, for example, 1 or 2 or 3, we can insert it there, or even the other value. For example, we want to find it in between. For example, we want to find the value at 2.5, so that we can insert it here, 2.5, yeah, and x value here, 2.5, and then we have the value of y. So this is the trend line, yeah. So this is the curve fitting. Now we finish getting the equation. Now we finish getting the trend line. Now the next step is to analyze how good it is, yeah, how good it is for the trend line. Yeah, so we will analyze the error, yeah. Yeah, wait for a moment. Yeah, so next for the error analysis. So what we want to find is that first we want to find ST and SR. Yeah, so ST and SR is the summation. Yeah, so here, yeah, so the summation here will be ST. So this one, the difference between the value and the mean value, that will be ST. This which represent the spread of the data to the mean value, and this one is the error, the residual, yeah, the spread of the residual. Yeah, so that here we just calculate this one. So once we have y bar value here, we have y bar value before here in the calculations, yeah, so that we can find it yi for each of the data here minus y bar value minus 3.42. Yeah, so for each of the data here, we subtracted with minus 3.4, and then we square the value, so that will be 8.5. Yeah, and so on. And for the error, how to find for the error? So this will be the value, yeah, the actual value yi minus the model, the value from the model. So A0 minus A1 xi. So once we have A0 and A1, so that we can find the value of the error here. So yi, the actual value, minus the approximated value from the trend line by inserting the value of xi here. So that we have the value, and don't forget to square the value. So this is the squared value for the error. And this, the summation will be ST and SR. So then, because we have the value of ST and SR, so that we can calculate the R squared value, the coefficient of determination. Yeah, coefficient of determination, the R squared value. And with this calculation, it shows that the result will be 0.868, or that also shows that 86.8% of the original uncertainty of the data has been explained by linear regressions. Yeah. Okay. So this is how to find the fitting a linear line as a fit for the data, and also to do the error analysis. Okay, any questions?
Noted, ma'am.
Okay, thank you. Yeah, you can ask if there is something that you do not understand yet. Yeah. Yeah. If we look at here, yeah. So the calculation is pretty simple. Yeah. So that we can apply this in computer very easy. Yeah. So you can imagine that how to perform this calculation in the computer. So you can, for example, write a program in Python. Yeah. To get a linear regression. So for example, you have this, you can create the array of the known value of the data. For example, you can create the array of xi and you can create the array of yi. And later you can create additional array to store the value of xi, yi, and xi squared. And also to do the analysis for the error as well. Yeah, for ST and SR value. So that once you have those arrays, so then you can find the summation of the array, and then you can find easily the value of A1 and A0. So that will be very easy to be applied in the computer, yeah, in the computer programming. Okay. So that is about linear regressions, and I think that is pretty straightforward, yeah. Nothing difficult. We just do repeated calculation with this array or this column in the data. Yeah, so you just do that calculations and quite simple arithmetic operation. Okay, so that now we can also calculate the standard deviation. Yeah, in which Sy is equals to St divided by n minus 1. So this is the standard deviations, which is 1.945. And we can also calculate the standard error of the mesh estimate, in which Syx there will be equals to square root of SR divided by n minus 2, so that the result will be 0.7735. So again, aside from the coefficient of determination, we can also compare this value. Yeah. So if we look at here, the value of the standard error of estimate is smaller than the standard deviation. It means that the value is also, the data that we have, the value is also, in general, the data itself has this particular standard deviation value. So the standard deviation value for the data is 1.94, but the error itself is lower, yeah, than the spread of the data. So this means that the linear regression is acceptable, yeah, so has good fitness, as long as the value of the standard of estimates is lower than the standard deviation of the data. Yeah. So this means that a good approximation for the trend line has been obtained. Okay, so this is the example of code, yeah, of the code. So this is written in Fortran, but very similar in Python as well. A little bit different on the syntax, but more or less is similar. Yeah, so we can create a subroutine or a function which is called regress. So this is to get the regression equation, in which we have the argument passes x. Yeah, so this is the data, x and y, and n, the number of the data, a1 and a0 is the coefficients that we want to find. Yeah, so y is equals to a0 plus a1 times x. And syx here is the value, the standard error of estimates, and r squared value here is the coefficient of determination. So that is very easy. Yeah, we can do the calculation by looping inside the array. Yeah, looping inside the array, so that here we have to I equals to from 1 to n. Yeah, we do the looping up to the first data up to n data, and we do the summation. So this is the process of looping to find the summation. Once we have the summation, so that we can find the mean value. And once we have the mean value and the summation for xi and yi here, yeah, and also x squared, so that we can find the value of a0 and a1. So once we finish with that, then we can calculate for st, yeah, the spread of the data and also the spread of the error, and then we can calculate the standard error of estimates, and also the R-squared value. Yeah. So very simple code, yeah, to find the linear regression. Okay, so that we can practice on this data. Yeah. So for example, we have several data here. Say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for example, we have 10 data, and then we have the value for y, for x and y value for the data. Now the question is, use least square regression to fit a straight line. So this is already learned, yeah. So we can easily again do the calculation, yeah. So that we have an x value, yeah, xi, yi, and then we can find value of xi, yi, and sigma xi, which is squared, so that we can write it down there, 5, 10, 15, and so on, yeah, 17, 24, and so on. And then we multiply that one, so 17 times 5, so that will be 5, 3, so 85, and xi squared will be 25, and so on. And then we do the summation, and then we can calculate A1 and A0. Yeah. So once we finish with that, yeah, we need also to find ST and SR, the spread of the data, yeah, and also the spread of the error. Yeah, so that we need to add another column, which is calculation of sigma yi minus y bar, which is squared. And also for the error itself, that will be sigma yi minus a0 minus a1 xi. Yeah, which is squared. So that we can calculate ST and SR, and then we can calculate the coefficient of determination. Yeah. So this is how to find the straight line. Now, if we look at the other question, B, we can also apply another trend line. For example, we have a power equations, yeah? Or we can also apply a saturation growth rate equation, or also we can apply a parabolic equations, and we want to plot the data along with all the curves. Now the question is any one of the curves superior? If so, justify. So this is the last question we need to address, is that which one will be the best fitting? Yeah, we can apply many fitting. Again, if you have the data, you can do this very easy in Excel. Yeah, I think many of you have used these tools in Excel, so that you can draw the graph. Yeah, you can draw the data points, you can draw the graph, and then you can get the equations by finding the trend line. Yeah, give a trend line in Excel, and in Excel you can choose any equations that you want. Yeah, for example, you can fit a straight line, you can fit a quadratic line or a cubical line, or the fourth order equations curve, yeah, parabolic curve, cubical curve, or fourth order equation, fifth order, or also power equations, yeah, and so on. So that the question is, yeah, we can choose any fitting, but the question is which one is the best fitting for our data. Yeah. So that to justify this one, to answer which one is the best, is by looking at how good the fitting that we have represent the data. So the answer is by finding the R-squared value here. Yeah. So it's very important when we do a curve fitting to check the coefficient of determinant value, coefficient of determination value. Yeah. So finding the R-squared value. So that if we have many curves, try the R-squared value and choose the one which closer, yeah, that the closest one to one value, yeah, to the value of one, yeah, as we've seen before. If we have a value which is close to one, yeah, so that means that 100% of the variable of the data is explained by the trend line. Yeah, so when we have many options to choose, then which one will be the best is by looking at this value. Yeah, so check for this value, which one is closer to 1, so that will be the best fitting. Okay, so because we have those questions, now we will look at the other options, to choose for the curve fitting. So we have here the power equations, we have the saturation growth, and so on. So we will look at another nonlinear approach, in which actually these nonlinear equations can be linearized. So we see here that we have special curves, special fitting that can be linearized. So we see here that there are a few types of nonlinear function that can be transformed into the linear regression problem. So these special functions are the exponential equations, the power equations, and last, the saturation growth rate equation. So these three equations can be transformed into linear regressions. Once we have it transformed, so that means we can use the same procedure that we have to find the linear line. So we will see the explanation for this. So for example, we have an exponential equation. So you know that this is the exponential equation in which we have exponent. So y is equals to a1 times exponential of b1x, or e to the power of b1x. So this is the exponential function. You see the graph is typically like this one. But with this graph, it can be transformed. For example, if we plot instead of xy, now we plot it in x and ln y, so that this curve will be a linear line in which the slope will be b1 and the intercept will be ln a1. And also here we see the second equation. Say we have the simple power equations. So the power equation means that we have a value which is powered, a value of x which is powered to a constant here. So that in this example we have y, which is equals to a2 times x to the power of b2. So that with this curve, we can transform it in the log x and log y plane. So we transform the coordinate into log x and log y, so that this curve will be transformed into a linear line. So this is called the linearization or linear transformation. So that here we have the slope will be b2 and the intercept will be log a2. So this will be the intercept. And if we have the third special curve, which is called the saturation growth rate. So what is the saturation growth rate? It means that it will be growing, with x, so the y value will grow with x, but then it will be saturated. It means that it will reach an asymptotic value. So this is called saturation growth rate. So what is this function? So this function can be represented by y equals to a3 times x divided by b plus x. So that if we transform it, so now instead of using x and y plane, now we plot it in the invert, so the invert, or 1 over x, 1 over y plane. So that this curve now will be linearized, so that now the slope will be b3 over a3, and the intercept will be log 1 over a3. So once we have transformed the coordinate, so that now we have the linear line to represent the curve, so that exactly the same procedure as before, so that we can use the linear fitting, the linear fitting that we have before to solve for this problem. Okay, so we will look in more detail of the explanation of how this linearization can be solved in the same function, in the same linear function. So for example, here we have y, the function is y equals to a1 times e to the power of b1x. So that when we try to transform it, so we give ln y, so that will be ln, if we make ln on the left and also on the right side. So to make that, the equation will be the same. So ln a1 times E P1 times X. So that will be ln Y will be ln A1 plus multiplication will be plus ln E to the power of P1X power will be moved to the front, yeah, move to the front, so that will be P1X times ln E. So ln E here is 1. Yeah, ln E is 1. So that what we have here, we have ln Y is equals to ln A1 plus P1X. It means that now we have to transform the new coordinate, transform it into the new coordinate, so that we will have Y star, the new value, that will be equals to A0 plus A1X, in which X here is the new value X star. But because this is equals to this one, yeah, so that we can write it down as X, so only X, that will be the same. Now Y value, the new Y value here will be ln Y. So this is the new value of Y. So what is the value of A0? So A0 will be ln A1 and A1 is P1. So that if you look at here, the slope is A1. So the slope will be P1. Yeah. And A0 is the intercept. So the intercept will be ln A1. Okay. So that we understand how we can transform it into the linear line now. Yeah. Now, please remember that if we already transform it to the linear line, it means that all the process in getting A0 and A1 here should using the new value, the transform value for Y and X. Yeah. So it means the new value for Y now becomes ln Y. The value for X remain the same. Okay. The second, which is about the power equations. Yeah, we have Y equals to A2 times X to the power of B2. Now to make it, to transform it so that we apply logarithmic, log Y, that will be equals to log A2 times X to the power of B2. So that now we have log Y, that will be equals to log A2 times, so that will be positive, power will be multiplication, so that P2 log X. So that we have the same equation here. So log Y equals to log A2 plus P2 times log X. So that now this becomes the new Y. That will be equals to A0 plus A1 times X star. So that X star here is log X. A1 is P2. Yeah, so that if we draw the new curve, the new plane, so that will be X star and Y star. Yeah, so X star value will be log X. Y star value will be log Y. And the intercept is A0, which is log A2. And the slope is A1, which is equal to B2. Okay. So this is how the transformation. Next, we have the saturation growth rate equations here. We have this equation. And then now we transform it into 1 over X and 1 over Y. So that we divide that, yeah. So 1 divided by Y equals to 1 divided by that one. So 1 divided by A3 X divided by P3 plus X. Yeah. So that if we calculate this one, so P3 can go up, yeah. P3 can go up there. So P3 plus X divided by A3 times X. Is that? A3 times X. Yeah. Okay. So that to calculate that one, so we have 1 over y. So that will be equals to B3 divided by A3 x A3 x plus x divided by A3 x. So that one is 1. So that we have y 1 over y. So that will be B3 over A3 times 1 over x separated, 1 over x, plus this is 1, so 1 over A3. Or we can write it down as 1 over y. That will be equals to 1 over A3, yeah, plus B3 over A3 times 1 over x. So if you look at this equation, so that will be the new y star. That will be equals to this one is A0 plus this one is A1 times the new x. Yeah. So if we look at here, if we look at here, so that we have the abscissa here will be 1 over x, the new value of x. Yeah, so that will be 1 over x. And the new value of y, that will be 1 over y. And the intercept or A0 is 1 over A3. This without log, yeah. So please check again. So this is without log. So this should be a correction without log. So only 1 over A3. Yeah, you can check again in the book. And the slope is here. So the slope or A1 here is P3 over A3. Yeah. Okay. Okay, so this is for the saturation cruise so that we can find, once we have linearize, transform it into 1 over x and 1 over y so that we have a linear form here, linear line, so that we can do the same as before. Okay. Okay, so to make it clearer, we will look at the example here. So say we have an equations, which is the power equations. Yeah, so we have the power equations. So when we have the power equation, so that we can find the log value, the log value. So that we have log y, that will be equals to log a2 times x to the power of b2. Again, the same as what we have done before here. So log y will be equals to log a2 plus b2 times log x. Okay, so that now we substitute log y here with y. Yeah, so this will be y. And this will be x value. Yeah. So that now A0 will be log A2 and A1 will be B2. Yeah, so that now we need to transform it. Yeah, the original value of x and y now need to be transformed into the new value of x and y, in which the new value of x will be log x and the new value of y will be log y. So that we find the new value here, which is shown by the capital sign, or sometimes we give a star there. Yeah, so that log x, so log 1 is 0, and so on. Log 2 is 0.301, and so on. Yeah, and y value as well. So log 0.5 will be minus 0.301, and so on. And again, we do the summation. Find the summation for sigma x and sigma y. Finish with that. Now we can find the multiplication of xi, yi again. But now when we multiply xi, yi and xi squared, now we use the new value. So the old value is not used because this is already transformed. So this is the one that we use. Yeah, so xi, yi here is multiplied from the new value. So xi, yi, so that will be 0. Hmm? Yeah, so that we have the value of xi and yi, and also xi squared now is taken from the transform values. So this will be the value, yeah. So that now we do the summation as well. Once we have the summation, so that we can easily insert that in A1 and A0. So A1 is n, the number of data points, so that will be 5. Yeah. Sigma xi yi is taken from the transform value, so that will be 1.424 minus 6 sigma xi. Sigma xi again. Yeah, so that we can find sigma xi. Now sigma xi is not taken here, but taken from the new value, the transform value. Yeah, sigma xi and sigma yi. And also that will be divided by n, the number of data, times sigma xi squared. Yeah, so we find xi squared. So we find the sigma, the summation, so that will be 1.169 minus sigma x, so sigma x is here. So this value is squared. So that will be 1.75. And then we can also find the average. So the average here is obtained from sigma y star divided by n. So that will be 2.141 divided by 5. So this will be the result. And this one as well, obtained from sigma xi star divided by n. So that we have this equation. Yeah. So this data, which is transformed, yeah, now become this one. So that we obtain the result for this data. Yeah, we obtain the trend line for the transform data. So the trend line here will be A0 minus 0.334 plus A1 times X plus 1.75 times X, time log X. Yeah, so that will be Y star will be equals to A0 plus A1 X star. Or that we can write it down, Y star is minus 0.334 plus 1.75 X star. So Y star is log Y, X star is log X. Again, we will look again at here. Now, what is A0? A0 is log A2 and A1 is B2. So that here we have A0 is equals to log A2, and that will be equals to minus 0.334. And A1 is equals to B2. So that will be equals to 1.75. So that we have the value of B2 directly. Yeah, we have the value of B2, but we don't have the value of A2. Yeah, again, this one will be Y is A2 X to the power of B2. Now, how to find the value of A2? So we have P2 already. Now we don't have the value of A2, so that A2 is calculated from here. So A2 will be equals to, that will be logarithmic 10. So 10 to the power of minus 0.334. So this is the value of A2, sorry. Yeah. So that this will be equal to 0.46. So that we insert it here. And B2 is directly similar to A1, so that we can use it. So this is the final equations that we have. Yeah. So this is the final equation. So this is the trend line. Yeah. For the fitting. Yeah. The power fitting. Yeah. Power fitting for the data. Okay. Any question?
Excuse me.
Yes, Sultan.
Ini mem, izin pakai bahasa Indonesia dulu mem.
Ya.
Saya masih bingung yang ini sih mem, yang apa? SY sama SY per X. Yang sebelum ini sih sebenarnya. Tadi kan ada because SYX less than SY, the linear regression model has good fitness. Nah itu kenapa mem? Saya masih bingung perbedaan antara SY and SY per X. Gitu aja sih.
Yeah. Oke, jadi SY itu terkait dengan standar deviasi persebaran data ya. Jadi persebaran data dari rata-ratanya. Ya. Jadi ini kalau kita belajar mengenai statistik ya, kita punya banyak kali data, kita punya beberapa kali attempt begitu ya. Nah ternyata hasilnya itu ada yang jauh dari rata-rata begitu. Jadi memang datanya sangat tersebar begitu. Nah kalau datanya tersebar, maka standar deviasinya besar begitu ya. Artinya memang penyebaran data itu cukup besar. Nah, kalau SYX di sini ini adalah penyebaran dari data terhadap regression line. Ya, penyebaran dari data terhadap regression line. Artinya data terhadap regression line ini artinya error begitu ya. Jadi berapa besar penyebaran errornya terhadap garis regresi tersebut begitu. Jadi memang pengertiannya agak berbeda, tapi sebetulnya kalau kita bicara standard deviation tadi, semakin besar standard deviation, artinya penyebarannya dari rata-rata makin besar. Begitu ya. Jadi penyebarannya terhadap rata-ratanya makin besar. Ya, jadi kalau ini kita misalkan katakanlah ini ya garis horizontal ini rata-ratanya begitu ya. Ini mungkin bisa dianggap ya di antaranya begitu ya. Ini adalah garis rata-ratanya. Nah, ternyata ini cukup besar gitu perbedaannya begitu ya. Cukup besar perbedaannya. Jadi artinya katakanlah ini rata-ratanya ya, kita tidak tahu persisnya berapa, tapi katakanlah ini mean value-nya rata-ratanya, maka kalau ada persebaran seperti ini, maka ST ya. Sebentar, tadi istilahnya apa tadi? Ya SY kecil. Ya, kalau ST itu tadi perbedaannya. SY kecil ya, jadi SY kecil. Ya, jadi SY kecil itu menunjukkan seberapa lebar ini. Ya. Seberapa lebar ini. Perbedaannya terhadap data yang kita miliki begitu ya. Nah, misalkan kita buat trendline semacam ini ya, kita buat trendline semacam ini. Nah, ini kan hasilnya selisihnya lebih kecil begitu ya. Jadi tidak sebesar persebaran yang terjadi terhadap rata-ratanya gitu. Jadi tidak sebesar persebaran yang terjadi terhadap rata-ratanya. Jadi kalau kita perhatikan di sini, kita membuat trendline di sini, yang kita cari adalah selisih dari masing-masing data terhadap trendline tersebut. Nah, ternyata kalau ini perbedaannya hanya sekian ya maksimumnya, maka lebarnya ini yang disebut sebagai SYX. Jadi sama-sama menunjukkan seberapa lebarnya selisihnya begitu ya. Yang satunya selisihnya terhadap rata-rata dari segi statistik, yang satunya lagi berapa besar perbedaannya terhadap trendline-nya, yang berarti artinya ini menunjukkan berapa selisihnya terhadap error begitu. Ya, seberapa lebar selisihnya terhadap error. Dan otomatis biasanya kalau ini lebih sempit, berarti data itu semakin mengumpul di tengah. Berarti begitu, artinya peaknya nanti ya jumlah frekuensi data yang lebih dekat dengan di tengah ini, atau dalam artian di tengah ini adalah semakin mendekati trendline itu makin banyak begitu. Nah, artinya ini hanya sebagai perbandingan saja begitu ya tadi ya, apa bedanya SY dan SYX. Artinya ini hanya dibandingkan kalau misalkan kita punya ini persebaran errornya lebih kecil daripada persebaran data, maka ini sudah lebih baik gitu, sudah baik begitu ya, hasilnya sudah dapat diterima. Seperti itu. Karena jelas makin data itu makin tersebar ya, sebetulnya ketika data itu makin tersebar, maka kemungkinan juga errornya itu akan makin besar begitu ya, karena semakin data itu tersebar semakin sulit untuk mendekati dengan satu single curve begitu ya, semakin sulit untuk mendekati data itu dengan single curve, sehingga kalau memang data itu tersebarnya sangat jauh ya, selama ini lebih kecil, nah itu dianggap bisa diterima begitu ya. Mungkin gitu penjelasannya.
Oh, oke, baik. Terima kasih banyak, paham.
Baik, is there any question? Any other question? Silakan. now we haven't finished yet with that. Yeah. So what we need to find next is to analyze the error. Yeah. So for the case that we have discussed there, we haven't analyzed the error yet. So we will see how to analyze the error. So basically the error analysis will be similar. Whatever fitting that you use, so that the calculation should be based on this. Yeah. So that you can calculate ST and SR, the spread of the data to the mean value, and also the spread of the error. And then later you can calculate the coefficient of determination. Yeah, coefficient of determination. Okay, so we will return here to analyze the error, so that we have to find ST and SR. Yeah, how to find ST, which is the spread of the data to the mean value. So that will be yi, the value of yi, minus y bar. So the value of y bar here is already known, it is 0.4282, and then we square the value. Yeah, we square the difference value. And also we have to calculate for SR. Yeah, SR here will be yi minus the y approximated from the trend line. So this is the approximation from the trend line, so that we can insert the value of x here in here. So 1 to the power of 1.75, so that will be 0.46. So that here we have 0.5 minus 0.46, and that is squared. Yeah, okay. So we do that calculations up until we find the summation. And once we have the summation, once we have the summation here, so the summation here will be ST and SR, so that we can calculate R squared value will be ST minus SR over ST, so that we have the result. Okay, so this is how to perform the analysis. So to check for the error, it's easier to use back to the original data that we have. Yeah, so back to the original data. If you want to use this one, this will be fine as well. Yeah, if you want to see this, it means that you calculate the error based on this one. So the result will be similar. Yeah, so you can choose any. Yeah, but be careful. Yeah, be consistent. Yeah, when we use the transform data, so use the transform data, or when you use the this one, so use this one. So yeah, try to use the correct equation. Yeah, try to use the correct equation. Okay. So that is for the error analysis. Okay. Right. Any question?
Noted, ma'am.
Okay. Yeah. Before we continue, yeah, I will do a bit of absent. Yes, I will call your name and please respond. Yeah, to check whether you are still here. Sergio.
I'm here, ma'am.
Okay. Nandana Gozi. Nandana Gozi. Not here. Okay. Raffi. Raffi Fadlur Rahman.
Present, ma'am.
Okay. Retno Trilestari. Retno. Not here. Okay. Abi Surya.
Present, ma'am.
Okay. Sultan. Salwa. Salwa Nisrina.
Yes, ma'am.
Benedicto. Fahrul.
Ma'am.
Yusuf. Yusuf Octavian. Not present, ya. Yohana.
Hadir,
Yo.
ma'am.
Okay. Vivi. Vivi absent, ya. She's in Pimnas, ya. If I'm not mistaken. Okay.
I'm sorry, ma'am.
Yes.
My internet connection is unstable. Do you call me?
Yes.
Okay.
Are you here?
Yes, ma'am.
Okay. Josia. Josia. Not attending. Yasir. Yasir. Yasir was here. Now it's not here again. Yasir? Prandito? Prandito Hasri? Not attending. Nicholas?
Yes, I'm here, ma'am.
Okay. Rahmat Agung?
Present.
Derivata?
I'm here, ma'am.
Kafka? Kafka Cordova? Not present. Okay. Krisnadi not attending. Alvin Dion?
Yes, ma'am. Bu, saya hadir, Bu.
Krisnadi. Belum absen Krisnadi.
Tadi terlambat absen, Bu. Nge-lag terus. Nggak bisa absen tadi akhirnya.
Masuk jam berapa tadi?
Masuk udah cukup pagi, Bu, sebenarnya, Bu. Cukup awal tadi. Tapi di classroom saya nge-lag terus. Sudah ganti browser juga tetap nggak bisa, Bu.
Ya sudah. Oke. Tadi Alvin ada. Yosef Ardiansyah.
Yes, ma'am.
Oke. Anggarda.
Hello, ma'am.
Timothy.
Yes, ma'am.
Edward.
Yes, ma'am, I'm here.
Oke. Muhammad Adim.
Present, ma'am.
Oke. Fauzan Zaki.
Yes, ma'am.
Harvin Mulyono.
Not present, ma'am.
Apringga Bima.
Yes, ma'am.
Dimas Aji.
Yes, ma'am.
Faiz Taruna. Not here. Okay. Farhan Rabani.
Yes, ma'am.
Anggito Kusumo.
Yes, ma'am.
Muhammad Fadel not here. Dirga Hedi.
Present, ma'am.
Okay. William Matthew.
Yes, ma'am. I'm here.
Okay. Abdul Ghani. Tidak ada ya. Pilih Ahmad.
Halo, ma'am.
Okay. Ivan Faza. Tidak ada. Agnes.
I'm here, ma'am.
Okay. Alright. Thank you. Ya. Just. Iya. Kenapa? Iya. Tadi sudah dipanggil. Kemana tadi?
Oh, tadi putus Bu, lewat gitu.
Oke.
Saya
Alright.
juga, Bu.
Kemana tadi?
Sama, Bu. Putus-putus juga.
Iya. Posisi di mana ini sekarang?
Di kosan, Bu.
Di mana kosnya? Di Surabaya?
Iya, Bu.
Sudah di Surabaya. Oke. Kok putus-putus? Di mana kosnya? Daerah mana?
Di Mulyo Sari, Bu.
Ya, mestinya nggak putus-putus ya di Mulyasari ya. Saya juga di daerah situ.
Iya, wifi-nya rada putus-putus, Bu.
Okay, yeah, just to make sure that you really attending this class because I cannot see you, yeah. And yeah, just to make sure that you're still following what I was talking here, yeah. Okay. All right. Okay. Thank you. Yeah, and I hope that you will be active. Yeah. So please, if you do not understand, please ask. Yeah. So if this is clear enough, please respond as well. Yeah. So that it's not like I'm talking by myself. Yeah. Perhaps only Sultan is responding. Yeah. Okay. Okay. Back to the material here. Yeah. Back to our topic here. So this is about the example of applying linearization, yeah, linearization to get the curve, yeah, for several spatial curve that we have discussed. Yeah, so there are three curves that can be linearized. Yeah, but we will talk about other regression technique here. And sometimes those fitting that we have learned is also still not a best representation for the data that we have. Yeah. So that here we will talk about extending the least square method to the higher order polynomial. So for example, we have this data, yeah, we have this sort of data in which this cannot be represented by a linear line. And also if we want to, for example, apply the exponential, or if we want to apply the power equations, or even the saturation growth rate equation is not suitable for this data. Yeah. And we might think that a parabolic equation might be preferable for this case. Yeah. So that if we want to use parabolic equation, it means that we will use the quadratic equations. Yeah. In which it means that the quadratic equation is a second order polynomial here, second order, the power to 2, yeah. Here. So second order polynomial is defined by y is equals to a0 plus a1 x plus a2 squared x plus the residual or the error. So that the residual will be yi minus this value, the model. Yeah. So that the squares, the sum of squares of the residual, so SR value will be this value which is squared, and we do the summation. So again, to find the value of A0, A1, and A2, it means that we have to find the gradient for each of that variable, and that gradient should be equal to 0. So that if we apply this one, we find del SR over del A0, so that will be minus 2yi and so on. And we now, that will be equals to 0. That is to minimize the value, to find the maximum point or the minimum point. Yeah. In this case, it will be the minimum value, the minimum residual value with the value of A0 here. And also we find the gradient in respect to A1, and that should be equal to 0 to get the minimum SR value. And also we find the gradient in respect to A2 here, yeah, in respect to A2, and that will be equals to 0. So that here we have 3 equations, yeah, 3 equations to find 3 unknowns for A0, A1, and A2. So that how to solve this one, because we have 3 by 3 system, so it means that we have to construct a matrix. So this is the example in which, yeah, what we have learned in the solution of the set of linear algebra equations will apply here. Yeah. So then now we can construct these equations to get A0, A1, and A2. So A0 will be n, yeah, so that the equation, the coefficient will be n, sigma xi, and sigma xi squared. So that's for the first equations. And that will be equals, the right-hand side is yi. The second equation, we have A0, A1, and A2 for the unknown. So the coefficient will be sigma xi squared, and sigma xi to the power of 3. And the right-hand side will be sigma xi yi. So this one. And the third equation, here we have A0, A1, and A2. So the coefficient will be sigma xi squared, sigma xi to the power of 3, and sigma xi to the power of 4. And the right-hand side will be sigma xi squared times yi. So this is the value. So this is the matrix that we have. So how to solve for the unknowns? It means that we have to fill in this matrix based on the data that we have. So it means that if we have xi and yi, so that we have to calculate the sigma xi and sigma yi, sigma xi squared, sigma xi to the power of 3, sigma xi to the power of 4, and also sigma xi yi and sigma xi squared yi. So once we have all of that value filled, so that we can find for the unknowns here. Yeah. So once we have the unknown, so then again we can calculate SR and also ST, yeah, with the mean value known, so that we can calculate the coefficient of determination. Yeah. Okay, so this is for the quadratic equations. And what about the standard error of estimates? So the standard error of the estimates now will be calculated by the square root of SR divided n minus 3. If before we have a linear line, so that will be n minus 2. Now for second order equation, so that now we have n minus 3. Yeah, so that in general we can expand further to higher order polynomial. So for example, here up to the power of m here for the equations. So that if we have this sort of m order polynomial, so that means we have to create a system the size of the coefficient matrix will be m plus 1 by m plus 1. So for example, here before we have two quadratic equation, we have two second order. Yeah, it means that we create 3 by 3 system. So that it means that m plus 1 by m plus 1 system must be solved for determining the coefficients of the mth order polynomial. And the standard error of estimates will be generally will be the square root of SR divided by n minus m plus 1. So the size of the system that we solve. And again, the coefficient of determination will be the same. Yeah, the calculation will be the same as before. Okay, so that if, for example, we have third order, so that we will create 4 by 4 system. We have fourth order, so that we will create 5 by 5 system and so on, so that we will apply what we have learned before. For example, we can apply Gaussian elimination, we can apply LU decomposition or other method, as well as the iterative method to solve for the unknown coefficient here for A0, A1, and A2. Once we have that value up to AM, so that we have the complete equations, yeah, for the fitting. Okay, so we will see the example here in which we have 6 data points here from x0 up to x5. Yeah, so 6 data points. And we want to fit the second order polynomial to the data. Okay, so based on this, we need the value of sigma xi, xi squared, xi to the power of 3, xi to the power of 4, xi yi, and xi squared times yi. So we create that on the table. Xi squared, xi to the power of 3, xi to the power of 4, xi yi, and xi squared yi. And we do the calculations, find the summation of each, and then we can apply that in the matrix. Yeah, finding the mean value as well, and then we put that in the matrix. Okay, how is the solution for this one? Go again back, recall what we have learned before. You can apply Gaussian elimination, and then you will have this solution, A0, A1, and A2. So once we have that, so we can insert that in the equation. So y will be equals to A0 plus A1 times x plus A2 times x to the x squared. Yeah. Okay, so this is the final equations, and then later you have to do the same error analysis. Yeah. Okay, so this is about linear regression. So this is the error analysis. You can calculate ST and SR, the error. Yes, so the error will be the difference of the y value here that we have from the system minus the value of here for each of the data, and we do the summation. We square that and do the summation. Okay, so that for this case that we have discussed, yeah, here is the calculation for the error. So that we calculate the y model for each of the data that we have here. So that now we can calculate the error will be yi minus y model, and this is squared. And we can also calculate yi minus y bar with the average when it's squared. So this will be ST. So that we calculate R squared will be ST minus SR, which is here, divided by ST. So we see here that the value is very close to 1. So 0.9985. So this means that 99.8% of the data has been represented by the fitting, yeah, by the polynomial or second order or quadratic equation here. And the standard error of estimates will be 1.12. Okay. Okay, so this is the example, yeah, of the second order, and you can apply to the higher order. Yeah, you can apply that to the higher order. Okay, so this is the problem that we've seen before. Yeah, so that because we have learned that method, so then we can try that. Fitting a straight line, yeah, a power equation, or the saturation growth rate, or the quadratic equation. Yeah, and we can justify which one gives the best fit. Yeah, which one gives the best fit. Okay, so that yeah, we can see here that you can try on that. Yeah. So this is the result. Yeah. In general, you can apply that in Excel. Yeah, you can apply this in Excel. So say you want to plot this graph in Excel, and then you can add trend. I think all of you perhaps already understand this one. So you can click on the right button and then click add trend line, and then you will show by this one. Yeah. Now you can choose whether you want to use exponential, which is what we have learned. Linear is also learned. Logarithmic, polynomial, power equations already done. Yeah. So you basically understand how Excel do this procedure, do this function. Yeah. So Excel is also using the same method that we have learned. Yeah. And the important thing is sometimes you already apply this one, but you do not understand that we can display the R squared value on the chart. So this is very important. So later, if you want to use Excel, try to tick on this one because by default, this is off. Yeah, this is not checked. Yeah, so that if you want to see which one will be the best fitting, so you can tick on that so that this will be displayed in the graph. So that we can see here that if we have this sort of data and then we apply the polynomial equations in which we use the quadratic equation here shown by the green line here for the data that we have there, so that we have the R squared value, which is 0.98. So this means that 98% of the uncertainty of the data has been represented by the quadratic equation. And if we choose here the linear line, which is shown by the black line here, so that we have here, the R squared value will be 0.838. So it means that it's only 83.8%. Yeah. And if we choose the power equations, so here is the power equation. You see, we have the same equation, yeah, as what we have done before. Y is equals to A2 times x to the power of P2. And here with the Excel, you can do exactly the same calculation, and the R squared value is 0.955. So here you can see, you can check which one that gives the best fitting. Yeah, which one that gives the best fitting. So in here we see that the second order equation or the quadratic equation here represents the data better compared to the power equation. Yeah. So this is very important that you can display the R squared value on the chart. So because now you understand the basic, you understand the concept. So now you can utilize that and see which one will give the best fitting. Okay, so I think that is all for today. Is there any question before I close this class?
Ma'am, can I ask questions? Ma'am, confused, ma'am.
Yes, Farhan.
Okay.
Yeah.
So to determine what trend line is the best is using the R function, ma'am, or not?
Yeah, so R squared value here. So display R squared value. So you can see it from here. Yeah.
Okay, thank you, ma'am.
Yeah. Yeah, so here what is provided in Excel is the R squared value. Yeah, so the coefficient of determination. And we can also calculate by ourselves. So if, yeah, you can check whether you have exactly the same result as an Excel. You can try it by calculating the same procedure that we learned. Yeah, so you can calculate xi, yi, xi times yi, and so on. So you can create your own equations and see whether you get the same result. Yeah, see whether you get the same result as what you have in Excel. Yeah, so you can check it by yourself. Yeah, so you will see that you will get the same result. Yeah, so basically the procedure that we have learned, yeah, is applied in any software. So what we have learned here is the basic, yeah, that will be applied in the software. So if you learn numerical method, yeah, if you learned computer programming, yeah, before, so you can make your own Excel software, yeah. So it's easy as that, yeah. So what we learn here is a basic so that you can develop further, yeah. You might not be interested to be a programmer, yeah, but at least now you know, you understand, yeah, how it works. And the best thing is that you now understand how to use it. Yeah. So perhaps you have used this before, but you don't have the basics, so you don't understand which one will be the best fitting. Yeah. So now when you learn numerical method, you understand how to do the analysis with the data. Yeah. Okay. So I think that is for today. Any other questions?
Ma'am, I just want to make sure about R square is equal to trend line, right, ma'am?
Can you repeat? Yeah, there is a delay. Can you repeat?
So for the R square, is it equal to trend line in Excel, ma'am? I just want to clarify it.
The trend line is the displayed equation here. So if you display the equation here, so you will have this one, yeah. So that will be, yeah. So I'll annotate this one. Okay, so when you have this one, display equation on chart, when you check that, so it will display the equation here. So this is the trend line, yeah. So this is the trend line. So this is the trend line when you add linear equations, and then you can add power equations, this one, and the green line here is the quadratic equation. So this is the trend line, yeah. Now R squared is the error analysis, how close it is to represent the data, yeah. And in order to get the R squared value, you have to tick on that one as well, yeah. So display R squared value on chart so that you will display this one, yeah. Because if you not tick that value, so it will not appear, yeah. So you can get the result, but you don't know how close it is to represent your data, yeah. Sometimes because you can use any function that you like, yeah. For example, you can use second order or third order equations, cubical equation. You can use any fitting, but you don't know which one is the best fitting, yeah. So with this, with the R squared value displayed with the analysis of R squared, you know which one will be the best fitting for the data, yeah. Okay. Okay, so is that answering your question, Sultan?
Okay, ma'am. It's answered.
Yeah.
Thank you, ma'am.
Okay. Okay. Right. So I hope that is clear enough. Yeah. And we will meet again next week, inshallah. Yeah. For the next discussion on what next integration, perhaps. Yeah. Okay. Okay. So yeah. Thank you for joining this class. I'll close this class. Wassalamualaikum warahmatullahi wabarakatuh.